Hello math students! In the previous video you learned about properties of function notation, which covered how to solve a function in function notation given a value of x, how to add, subtract, multiply, and divide different functions. And so that's where we're going to start with our warm-up today. So if you need to look back at your notes on function notation to help you with this, go ahead and do that. Take about 5 minutes to try these problems, and then continue on the video and I'll show you my solutions. So welcome back. I thought we would walk through this problem together for right now, just because I know that this one can be a little bit challenging. So for part A, I am given function f and I am given a unique input for f. So the input that I'm putting in for f is 2b plus 1. And so that means when I see f, instead of an input of just x, I'm going to put 2b plus 1. So that is what I'm going to put into my function instead of x. So this will equal 5 minus 3 times 2b plus 1. So I substituted 2b plus 1 in for x. And now I will simplify this by distributing the 3. And I need to make sure to distribute negative 3. So that will be negative 6b. And then negative 3 times 1 is minus 3. I can combine the 5 with the minus 3 to be 2 minus 6b. So that is that expression simplified. And then in part B, I'm supposed to multiply the two expressions together. I'm going to make sure to use my parentheses. And now I have to multiply every single thing together, so it's always good to be careful and do one piece at a time. I like to draw the lines to help me remember what I've multiplied. So 5 times x squared is 5x squared. 5 times 1 is 5. Then I have negative 3x times x squared is negative 3x cubed. And negative 3x times 1 is minus 3x. In this case, there's nothing I can combine together, so I could leave my answer like this. In general, it's proper math procedure to put the powers in descending order, so from greatest power to smallest power. So I could rewrite it like this: negative 3x cubed plus 5x squared minus 3x plus 5. These are the same answer. The bottom one is just slightly more proper notation. So that is the solution to the warm-up, reviewing what we learned last video on function notation. Alright, so we have a new definition here, which is composition functions. And so a composite function is created when one function is substituted into another function. It sounds a little complicated, but essentially this is another function operation. So you already know about the operations: addition, subtraction, multiplication, division. You also know about powers and square roots. A composition is just another operation on a function, and this one is putting one function inside of the argument of another. Okay, so below there is a very basic example where you can see what the notation looks like. So this is what we call a composition or composite. You can use either composition or composite. And this is pronounced f of g of x. F of g of x. Another way that you might see this notation, I will use the notation that is on the slides right now, but just in case in the future in college, you also might see this written like this. It looks like fog, I know, but it's like a little O, like f of g of x. So you can think of the O as of. F of g of x. And then over here, when I have g of f of x, g of f of x, that would be written like this. which looks like golf. So g of f of x. So in the middle is just like a little o. So that is the different notation. But you can see with the red and the blue color coding how g is put inside of f in the first example. So in the first example on the left, g is put inside of f, and then it is simplified, and then the example on the right, f is put inside of g and simplified. So these are some simple examples, and then we'll move on to the next slide, and we'll work through a little bit more challenging examples together. So let's choose some colors. We'll do f as, what was it? Red. So f can be red. And we'll make g blue. Like that. Okay. And now let's take the composition. So the first one, I have g of f of x. So this will equal, I have my g, and then instead of f of x, I'm going to write what the actual equation for f of x is. So the equation for f of x is 2x squared plus 3. So that goes in the parentheses. Okay? So what this will look like if I write this in terms of g is 5 minus x, but instead of x, my input is now 2x squared plus 3. So that is what I will write. This is a square. 2x squared plus 3. Okay. At this point, I've already fully taken the composition. I don't have any more functions. I don't have f or g left, so I've taken the composition, and I just need to simplify my function. So I will just simplify in black. I'll start by distributing the negative sign, and then combining like terms. So 5 minus 3 is 2, minus 2x squared. That is my answer. In part B, we're doing it the opposite. So I see that I have f is on the outside and g is on the inside. So g is 5 minus x. And so then now when I write in my f, I know f is 2x squared plus 3. Oops, 3. That was a weird 3. But instead of x, I have my function 5 minus x. At this point, I've fully taken the composition, I've replaced my f and my g, so I just need to simplify, and I will do that in black. The first thing I have to simplify is this x squared. So in PEMDAS, you do parentheses and exponents first. I want to remind you that 5 minus x squared is 5 minus x times 5 minus x. Okay? Some students like to try to just distribute the square inside of the parentheses, but you're not allowed to distribute powers like that. You need to remember that a square is multiplying something times itself. So 5 minus x squared is 5 minus x times 5 minus x. That is something students forget, and we're going to work on that this year. So that means I do have to multiply everything out. So 5 times 5 is 25. 5 times negative x is minus 5x. Negative x times 5 is minus 5x. And then negative x times negative x is plus x squared. And then I can distribute my 2. I know that these combine to be negative 10x. So I'll just write that negative 10x there. Distributing my 2, I have 50 minus 20x plus 2x squared plus 3, and then I can combine 50 with 3, and I'll write it in the proper order. So this is 2x squared minus 20x plus 53. That one, the simplification was a little work, but always good to practice our algebraic simplification. And finally, we have part C, which I don't know if you noticed, but that is actually a composition function inside a composition function. So it's 3 functions, all in which are inside of each other. So the first function that we have is g. We've got our g. And then inside of g we have f. And then inside of f we actually have this other function, which is, it doesn't have a name, it's just x plus 1. So instead of a function inside of a function, we actually have a function inside of a function inside of a function. Whoa! So I'm just going to show you the setup for this one, and not all the algebraic simplification like we did in the last part. So we are going to start, oopsies, we're going to start on the inside first. So I'll just leave this outer function g as it is, and I'll put this long parentheses so we can write everything that's inside of there. So inside of g I have f. So f, I'll do in red, is my 2x squared plus 3. But instead of x, I have the function x plus 1. Okay, so far what I did is I took this part right here, the f of x plus 1 is right here. And I just left the g by itself. So I found f of x plus 1. Now, what is inside the argument of g, I'm going to put into my function g. So my function g is 5 minus x. But instead of x, I'm going to put everything that's inside the argument. So I have my 2, x plus 1 squared plus 3. And so I hope you can see with my color coding, on the very most inside I have my x plus 1, and then farther out I have my function f, which is 2x plus 1 squared plus 3. And then even farther out I have my function g, which is on the outside, which is 5 minus everything that was in the inside of g. So I'm not going to simplify this because that would just take a little bit of time. However, you honestly should be able to. It would take a little time, but you should be able to simplify part C just like we were able to simplify part B. But I'll leave this one like this just so you can see that beautiful color coding, what it looks like.